Welcome to lesson 6.2, Isosceles triangles. So as we go through this lesson, we want to keep in mind the big idea that isosceles triangles possess properties that scalene triangles do not. And a refresher on a couple of vocab terms, a scalene triangle is a triangle where no sides are congruent. So all three sides are different lengths. An isosceles triangle is a triangle where two or more sides are congruent. And then we also have equilateral triangle where all three sides are congruent. So an equilateral triangle is a special type of isosceles because again, isosceles means two or more sides are congruent. So let's look at this first piece of our notes. And it says the angle determined by congruent sides in the isosceles triangle is called the vertex angle. So if two sides are congruent, the vertex angle is the angle created where those two sides meet. The side opposite the vertex angle is known as the base. So if we're dealing with an isosceles triangle, the base is opposite the vertex angle. And then the base angles are the two angles that help make the base. So the reason we need those vocab terms of vertex angle, base, and base angles is that they come up in our different theorems. So the isosceles triangle symmetry theorem states the line containing the bisector of the vertex angle of an isosceles triangle is a symmetry line for that triangle. So if I would draw the perpendicular bisector of my vertex angle, this line, the blue line here that it creates, is the symmetry line of that triangle. Then, two other vocab terms, an altitude and a median. So in a triangle, the segment from any vertex perpendicular to the line containing the opposite side, that is known as an altitude. So an example is right here. An altitude is from any vertex and it's perpendicular to the opposite side, and that would be an altitude. The median is the segment connecting a vertex of the triangle and the midpoint of the opposite side. So a median goes from the vertex to the midpoint of an opposite side. So in an isosceles triangle, there's a special relationship with the median and the altitude, which is right here in the isosceles triangle coincidence theorem, which states in an isosceles triangle, the bisector of the vertex angle, the perpendicular bisector of the base, meaning the altitude, and the median to the base are all determined the same line, meaning they're all the same line. So in an isosceles triangle, the median to the base, the altitude of the base, and the symmetry line are all the same line. So that is the isosceles triangle coincidence theorem. Then we have the isosceles triangle base angles theorem. And what this states is if two sides of a triangle are congruent, the angle opposite those sides are congruent. So in an isosceles triangle, the base angles are always congruent to each other. So the angles opposite the congruent sides are congruent. So our two base angles In this one, y and z would be congruent to each other. So let's look at these. Example 1, a proof. Given the figure at the right with segment AB congruent to segment AC, marked here in the image, and angle 1 congruent to angle 2. So angle 1 here congruent to angle 2. They want us to prove that line BC is parallel to line ED. So first thing, AB congruent to AC was part of our given information. Angle 2 being congruent to angle 3 comes from the isosceles triangle base angle theorem, because right here, triangle ABC, we know is isosceles because these two sides are congruent, meaning angles 3 and 2, the base angles, are congruent. Then they gave us that 1 is congruent to 2, so that's given. And then if we look at the previous two steps, if 2 is congruent to 3 and 1 is congruent to 2, the transitive property of congruence allows us to say angle 1 is congruent to angle 3. And if we look at angle 1 and 3 in relation to lines BC and ED, angle 1 and 3 are corresponding angles. So if corresponding angles are congruent, we can use the corresponding angles postulate to state that line BC and ED are parallel. Now example 2, again, is using some of our isosceles triangle theorems, and in this case it says given segment PI is congruent to PT, which is also congruent to PS. So PI, PT, and PS are all congruent segments. TP bisects angle ITS here on the bottom. The whole angle ITS was 148. Sorry, I'm skipping ahead. Angle ITS was 148. Determine the measure of angle IPT. So in this case, we knew TP was bisecting angle ITS. So ITS being bisected, we'd divide that by 2 to find out how much each part was. So PTI, P to T die, this angle right here, was 74 degrees because the big angle was split in half. Then we can use the isosceles triangle base angle theorem. If angle T down here was 74, I is also 74 because they're in an isosceles triangle. So if we know the two base angles are both 74, a whole triangle, PTI here, is 180 minus 74 and 74, giving us the measure of angle IPT being 32 degrees. Then we have the converse of the isosceles triangle base angle theorem, which states if two angles of a triangle are congruent, the sides opposite those angles are congruent. So if we're given two angles being congruent, we know those sides opposite are congruent or equivalent. So what that allows us to do is something like example 3 here. We knew these two angles were congruent, so this side and this side must also be congruent. So to find x, we would set them equal to each other and solve for x. So subtract the 3x from each side, then subtract the 12, and we are left with x equals 3. And then we get into our last couple theorems, the unequal sides theorem and the unequal angles theorem. The unequal sides theorem says if two sides of a triangle are not congruent, then the angles opposite them are obviously not congruent. And the larger angle is always opposite the larger side. So an example here, if we were given side AB being 8 and BC being 12, we know side BC is greater than side AB. So that tells us the angle opposite of side BC, angle A, is greater than the angle opposite side AB, which is angle C. So angle A is greater than angle C, or the measure of angle A is greater than the measure of angle C. Then we have the unequals angle theorem, which states if two angles of a triangle are not congruent, then the opposite sides are not congruent. The longer side is opposite the larger angle. So if angle A was 50, angle C was 35, 50 is larger than 35, so segment BC would be greater than segment AB or BA. And then our last piece, example 4. Example 4 says G. Willikers, Hollywood, and Izzy Wright were at 3 places in their neighborhood as shown below. Who is closer to Holly? Is it G. Williker or is it Izzy? So who's closer to Holly? So Holly's down here in the bottom left vertex. G. Williker is in the bottom right. Izzy Wright is at the top. So Holly has a measure of 60-degree angle. G. Willikers has that 70-degree. Izzy has that 50. So is the distance from Hollywood to Izzy or Hollywood to G. Willikers shorter? Well, 70 is opposite the x, 50 is opposite the y, so we know this side x is larger than this side y, meaning that G. Willikers, this distance of y, would be closer than this distance of x. So G. Willikers is closer to Holly than Izzy. Now you can ignore these problems numbered down here. In Google Classroom, you'll see the right numbers for this lesson, which should be 1 to 19 odds.